talking about protocol layering in the last part of the session, and we had seen that how, in case of complicated communications or in case of communications which require more than one step, we will need to divide the task of communication between several layers or between several systems, you can say. So, this whole idea of dividing a complex task into numerous simpler tasks to solve a particular problem or to accomplish a particular idea or accomplish a particular task is known as modularity. Right. So, modularity basically is the case in which we create independent layers. Particularly in this case, modularity means that we are creating independent layers, and basically a layer is nothing but it works like a black box, right. So, it has got some inputs and you have some outputs, and it's like abstract, and therefore there is no concern about how the inputs are changed into outputs. Right. So, it is like you provide some inputs, you get certain outputs, but you do not know how the input is getting converted into an output. So, therefore, the whole concept of protocol layering will involve this modularity, where we will have independent layers which will work in this fashion. So, if we say that if we have two machines and the two machines are given the same inputs and the two machines will give you the same output, then we can say that the machines can replace each other. Okay. So, if in our example where the two neighbors or the two friends were talking to each other, so if the two machines which they procure in two different cities are from two different manufacturers, but the task which is assigned to the machine, that is the task is to convert the plain text to ciphertext, that is encryption, and from ciphertext to plain text, that is decryption. So, as long as the machines are doing the same task, so they can be replaced. So, we can say that the two machines which create the same task, so they can do the same job, right. So, therefore, these machines can be considered as a part of the layer, because they are performing the same task, given the same input, they are giving the same output, right. So, another very important advantage which is noted in case of protocol layering is that even in case of simple communications, of course, this cannot be revealed, but when you talk about protocol layering in a complicated network, in more complex networks like the internet, right. So, in there that communication is not always using only two end systems, because internet is a very complex network, right. So, it requires and it has got multiple connections and interconnections between. So, there are not just two end systems which are talking to each other, there are a multiple intermediate systems also that need some layers and not all the layers, right. So, if we did not use protocol layering, then we would have to make each intermediate system as complex as the end systems, right. So, the end systems, if you are dividing the task into multiple systems and at each stage you are putting a different system, so then what are you doing basically? You are reducing the complexity, and therefore you are reducing the cost of the end systems also. So, if you need a system in which only the last two or the first two layers are required, only those two steps are required, then you need not have the complete system with a complete complicated system installed in place. So, therefore, this is also a method by which the cost of the whole system is reduced. Definitely there is one disadvantage which cannot be argued, that if there is no need for each layer to provide a service to the upper layer and give a service to the lower layer. So, therefore, we can say that the two stakeholders who are communicating, they could find and build one machine that could do all the three tasks. That's agreed that they can do all the tasks in one machine. But the point is that if that machine does not work, if that machine is broken, right, then you have to replace the entire machine with a new one, instead of just changing the machine in the second layer. So if therefore this problem or this advantage of protocol layering, it definitely outpasses the disadvantages, and therefore protocol layering is the function, is the way in which the network architectures are designed. So there are two main principles of protocol layering that we discuss. The first principle is that the communication is always happening in bidirection, in both the direction, right, and we need to make each layer so that it is able to perform opposite task, one in each direction, right. For example, if one layer, if say for example the third layer is listening, then the third layer in the other side has to talk. The second layer in one side is encrypting, so the second layer in the other side will decrypt. The first layer is sending, so the first layer in the other side will receive. So what we are saying is that the two layers, they act as complement to each other, they perform the same task but in opposite direction. So this is the first principle, that the communication between the layers is always going to be bidirectional. The second, the two objects under each layer on both the sides, they are identical, right. That is, the object in the third layer, the object is plain text, so the output of the third layer on the other side also has to be plain text. The object under layer 2 on both the sides has to be ciphertext. The object under layer 1 at both the sides should be a piece of the mail. So this is another important aspect, that the layers, they perform the same task but in opposite side. Then the two objects at each layer should be similar. So whatever objects we are having in one side, the similar object should be there on the receiving side also. So this is the source side, the destination side, both should match. Okay. The other important thing that we need to discuss here is that there are logical connections, that is, we have layer to layer communication, right. That is, Anne and Maria, the two stakeholders or the two neighbors whose example we are carrying up, they can think that there is a logical or imaginary connection at each layer through which they can send the object created from that layer. So this is only a virtual connection, but because the layers are performing opposite tasks and the similar objects are being generated, therefore we can say that there is a logical connection between the two layers at the two different ends. So that layer which is talking has a connection to the layer which is listening, because at both the layers you have plain text. At the layer 2 both the layers have got ciphertext, and at layer 3 both the layers have got a piece of the mail. So therefore there is a logical connection between these two layers that establishes that the layers, they are working complementary to each other on both the sides, right. So after we understand that how this layering architecture is working, how the different tasks or how the different activities involved in data communication are divided, we can understand how the TCP/IP protocol suite works, right. So the TCP/IP protocol suites, of course, it's one of the most common topics when we talk about networks which is discussed. So it is a protocol suite basically. So its suite means that it is not one protocol, but it is a set of protocols which is organized now again in different layers. Okay, and this protocol suite is used in the internet today. Okay, so this is a hierarchical protocol basically, and as we have already seen that it is made up of interactive modules, because we were talking about modularity. So now we can also call these layers as modules, and each of the modules or each of the layers will provide a specific functionality within the entire purview of computer communication, right. So the TCP/IP protocol suite is known as hierarchical because every upper level layer, every upper level protocol is supported by the services provided by one or more lower level protocols. Okay, so the lower level protocols will provide the services, will provide the input which is used by the upper level layers or upper level modules or upper level protocol, right. So, the original TCP/IP protocol suite, now this is one of the oldest protocol suites which is being followed and it is still being followed, right. So, it is one of the most successful protocol suites, one of the most well accepted protocol suites which is working, which is running behind the internet. So, the original TCP/IP protocol suite, it was defined as having 4 software layers, okay, built upon the hardware. So, the lowest layer was that, or the physical layer or the hardware layer. Of course, now the TCP/IP protocol suite which is used, it has said to have 5 layers. So, now it is known as a 5 layer model, earlier it was a 4 layer model, right. So, if you look at the original model, it had got the hardware devices, on top of which you had the network, the internet, transport and application layer. So, this was the original layers, but now the layers which are used recently and in the reference book which has been given, this is the physical layer, the data link layer. So, the hardware devices are now known as the physical layer, the network interface is known as the data link layer, the internet layer is known as the network layer. Of course, the application and transport layer remain the same. So, basically in the original layers there was no physical layer which has now been inserted and which is now being considered. So, therefore, the same layered architecture that we have been discussing is now coming to a practical reality, and we can see how these layers are formed and how communication on the internet will work in these layers. So, it is important also to see that each of these layers will perform a specific task, okay, and it has a very well defined role to play, and the layers are complementing each other to at the sender's end and at the receiver's end. So, if we look at this picture, it shows how the communication will take place through an internet. So, we have source A which is trying to send some data to a destination B. Now, it's seen that both the source A and source B, they have the 5 layers of the TCP/IP protocol suite, and both these source and destination are connected to each other through 2 types of devices. So, we can see here 2 types of devices are there. One is known as the switch, or which is also known as the link, and the other is known as the router, right. So, now these are specific devices which also work to provide connectivity, to provide routing services and to act as a link between the 2 networks. So, if we look at what is the role of these devices, so in detail also we will study the functionality, and in detail also we will look at what are the functions of a router, how does it work, what is switch and what are its specific functions, but at the moment we will only see what are the layers at which the router and the switch work. So, it is important to see that the router here which is seen, it is working on 2 layers on 3 layers basically, the physical layer, the data link layer, and there is a common network layer on which the router is working, right. Whereas, the switches they are connecting at a link level, right. So, the router is basically involved in 3 layers. There is no transport and application layer in a router, okay, because the router is only used for routing the packets through the shortest distance. So, application and transport layer have got no business in that. It is only how the data is going to travel. So, although a router is always involved in one network layer, okay, it is involved in n combinations of link and physical layer, in which n is the number of links that the router is connected to. So, because if your router is connected to 2 links, then it will have links to 2 physical layers and it will have links to 2 data link layers, but it will have connection to only one network layer, because the router is the device which will work at the network layer, right. The reason is that each link may use its own data link or physical protocol, right, because when we are talking about the links, like for example when we are talking about links here, so the router which is connecting link 1 and the router which is connecting link 2, is actually having three links. One is through A to B and to C, but when the packet is going from A to B, only two links will be used, but the router needs to have for each connection or for each link it needs to have data link connection, it needs to have the physical connection, right. So therefore, in this case also we are seeing that the router is involved in three links, and but the message will go from one source to one destination. So it will involve only two links, right. So each link may be used for using a different link layer and physical layer protocol. Say for example, one part of the network is using a different architecture, it is using a wireless connectivity, the other may be using wired connectivity, and then the router is used to send the packet from one end to the other. So therefore, they can have different physical layer protocols which are functioning. The router only needs to receive the packet from link 1, okay, and it is based on one pair of protocols, and deliver it to link 2 which is based on another pair of protocols. So therefore, for both the sets of protocols the router needs to have the physical and the link layer, but the network layer is only a single network layer. Now if we look at the switch which is installed, now the switch is basically installed at a link layer. Okay. So there is no network layer in the switch, it is only working in two layers, one is the data link and the physical layer. So switch has got two different connections, the connections are in the same link which uses only one set of protocols. So therefore we understand that a router is different because it works in two different protocols, two different physical layers, two different data link layer, but a switch will work on one data link and one physical layer. Why? Because a switch is connecting computers within a particular LAN segment, whereas router is connecting the computers or connecting the devices from two different networks or two different network segments. So therefore, a router is working at three layers, but whereas a switch is only working at two layers, the data link layer and the physical layer. So if we look at the different layers which are involved in the TCP/IP, if we look at the logical connections which exist between the TCP/IP, it becomes all the more clear that how each of these layers is going to communicate with each other, and how the switch and the router, they are placed between them. So first the switch is working at one LAN, that is segment 1, and the other switch is working at the LAN 2 or the link 2, and then there is a router which connects the link 1, the link 2 and the link 3 through the two destinations, right. So the TCP/IP layers, now if we look at the different layers of the TCP/IP, so we understand that the duty of the application and the transport and the network layer is end to end, whereas the duty of the data link and the physical layer is hop to hop. Now what does this mean? That when data is being transmitted on the internet, the domain of duty of the top three layers is the internet, whereas the domain of duty of the two lower layers, that is the physical and the data link layer, is the local. Okay, so it's the link, within that link only these two layers will work, the physical and the data link, whereas the network, the application and the transport layer, they will work at the level of the internet. So they will ensure, these three layers will ensure that the packet reaches from the source to the destination, whereas in the lower two layers, that is the physical and the data link layer, will only ensure that the packet reaches the next hop, whether the next hop is a router or the next hop is the switch, the duty of the layers ends there only. So the top three layers, the data unit or the packet should not be changed by any router or any link layer switch. In the bottom two layers, the packets which are created by the host can be changed only by the routers and not by the link layer switches, because the routers, they have this duty to send the packet to the most efficient path. So the router can make this change, the router can change the structure of the packet. Packet is nothing but the data which is encapsulated, and along with the data there is some extra information like the source address, the destination address, the error correction bit, all this information also comprises the packet, right. So, if you look at how the objects are created, identical objects which work in the TCP/IP protocol suite, we see that the objects which are working at the application layer, that is the message, because the message is being sent and the message is being received. So, the application layer at the source or the sender will send the message, and that at the receiver will receive the same original message, right. At the transport layer, the packet or the object, it is converted into segments which are also known as user datagrams, right. So, these two remain the same. Then coming to the network layer, the object becomes the datagram. At the data link layer, it becomes the frames, and at the physical layer, the frames are then converted into bits, right. So, this is how so what we are seeing here is that your network layer, the data link layer and the physical layer, your basic object is getting converted, the basic message or whatever data is to be sent, it is getting transformed, it is getting converted. So, the top two layers will not make any change in the message, any change in the data, but the bottom three layers will make. The router basically, which is working at the network layer, can make changes into the structure of the packet or in the structure of the data unit which is going to be shared. So, the logical connection at the network layer is between the two hosts. So, we can say that identical objects exist between two hops in this case, because a router may fragment the packet at the network layer and send more packets than received, okay, because we are saying that the router is dividing the data into smaller packets. So, if it receives one packet, it can divide that one packet into two or more than two fragments, and then it can route those packets, right. So, therefore, the delivery which is happening in the lower layers is hop to hop delivery. Okay, so, the link is between two hops, and the link between the two hops will not change the object. It is the between the when the router is working, when the router is fragmenting, then the packet can be fragmented and then the packet can be sent. So, if we look at the functions of the individual layers in the TCP/IP protocol suite, so we begin looking at from the lowermost layer or the first layer which we call as the physical layer. So, the physical layer, as we had seen in the original model, the physical layer was also known as the hardware layer. So, the physical layer is responsible for carrying individual bits in a frame across the link. So, what happens is that as the packet it traverses from the application layer to the physical layer, finally the frames are converted into individual bits, and from the bits is the data which is going to move through the transmission medium. So, because the physical layer is the lowest level in the TCP/IP protocol suite, therefore, the communication between two devices at the physical layer is still a logical communication, right, because there is another hidden layer, that is the transmission media under the physical layer. So, the real physical communication happens through the transmission medium, but above the transmission medium you are again abstracting the transmission medium, and you have a physical layer which is also logical, right, because here the data is converted in the form of frames, and from the frames it will be converted and transmitted in the form of bits through the transmission medium. So, we need to know that the transmission medium does not carry the bits, it carries electrical or optical signals, right. So, the bits which are received in a frame from the data link layer are transformed and sent through the transmission medium. So, whether your media is a wire, if it is a metallic wire, then your the data will be sent in the form of electrical signal or voltage. If it is an optical fiber, then the data will be sent in the form of optical signals, right. So, the physical layer what will it do? It will convert your frames into these signals, right, and these signals are then transmitted through the media. So, we can think that the logical unit between two physical layers in a two device is a bit. Okay, bit means the binary digit, that is either a 0 or a 1, and there are several protocols which will transform the bit into a signal. So, for logical understanding, the unit is bit, but actually the bit is converted into an optical or an electrical signal, okay, and that is transmitted through the transmission medium. So, the function of the physical layer is basically to take the frame from the data link layer and to convert it into a format basically, so that it can be transmitted, it can be taken up, it can be converted into a signal, the bit can be converted into a signal which can be transmitted through the transmission medium. The next layer, which is above the physical layer, is the data link layer. Now, we have seen that internet is made up of several links, right, we've talked about it. There are several LANs, there are several WANs which are connected by routers, and the LANs are connected by switches, etc. Now, there may be several overlapping sets of links that a datagram can travel from the host to the destination, and the routers basically are responsible for choosing the best link. Right, we have already discussed this, that the router is the device which is whose purpose or whose duty is to find out the best possible route for transmitting a particular packet. Now, when the next link to the travel is determined by the router, the data link layer is responsible for taking the datagram and moving it across that particular link. So, the router will determine which is the best link through which the the packet has to go, and the data link layer will actually send the packet through that particular link. Therefore, this is known as the data link layer. So, the link could be a wired LAN with a link layer switch, it could be a wireless LAN with a wired WAN, or it could be a wireless WAN. Okay. So, basically we can also have different protocols used with any link type. So, in each case, whatever the architecture may be, the data link layer is the layer which is responsible for moving the packet through the link which has been identified by the router. So, TCP/IP does not specify or it does not define any specific protocol for this data link layer, and it supports all the standard and proprietary protocols which are used, right. So, any protocol that can take the datagram and carry it through the link suffices for the network layer. So, basically the data link layer, it takes the datagram, it encapsulates it in a packet called a frame, and each link layer protocol may provide a different service. So, there are different link layer protocols depending upon what is the nature of the link on which the packet is to be forwarded, or how the encapsulation of the datagram has been done. So, these link layer protocols, they will provide error detection, correction, and they will also provide error prevention in some cases. So, therefore, data link layers protocols, they are not specific protocols which are defined, but most of the protocols which work at this layer, they will perform all these functions. So, we will continue with our discussion on the other layers of the TCP/IP protocols in the following lectures. Till then, keep watching CEC live lectures. Thank you.